This is the second part of projectile motion. How to answer a projectile motion problem. Here is an example of a projectile motion problem. This is from the 2016 paper for mechanics. As you can see, that they provide you with diagrams, and there would actually be spaces between each of the parts. So let's have a look at each of the parts in turn. The first part, it says, show that the initial vertical component of the velocity's fall is 12.9 meters per second. To do this, we need to note that we have got 20 meters per second going up at the angle of 40 degrees. So we need to convert this into its two components, because what we are interested in is the vertical component, Vy. We also know that this is 20 meters per second on this side. So if we look at sine, which is opposite over hypotenuse, which will equal the opposite sine, which is Vy, over the hypotenuse, which is 20. So we need to have 20 sine, and the angle is 40 degrees, will equal Vy, which gives us Vy equal to 12.8558, which if we round this, Vy will equal 12.9 meters per second, as they asked us to show. Let's have a look at the next part of the question. Calculate the time it takes to the ball to reach its maximum height. This is looking at the problem from a vertical aspect, and that is what we're interested in. We know vertically gravity has an effect, so we need to use the equations of motion. So the first step is to write down what we know. We have got the initial velocity in the vertical direction as 12.9 meters per second. This is the one that we calculated in part A. We know that this velocity is going directly up. We know at the top, at the maximum height, Vf vertically will equal 0. And we also know that the acceleration will equal gravity, which equals 9.8 s minus 2, and that is down. We want to know t. So now we've written down what we know and what we want to know, we have to choose an equation. In this case, we'll use Vf equals Vi plus At. So Vf is 0. We're only looking at the vertical motion, so we don't have to worry about how fast it's going horizontally. Vi vertically at the start was 12.9 meters per second, and to that we have to add A, which is 9.8. But this was downwards, so we need to remember that if we're assuming up is positive, that this will be a negative. And then we'll multiply that by t. So we've got 0 equals 12.9 minus 9.8 t. Rearranging and solving, we get and t works out to 1.3163 and so on, but we would need to consider how much to round this to. Generally, the information has been given to us as 3 decimal places, so we would make it t equal to 1.32 seconds. Okay, so that's part B done. Part C. This time, calculate the horizontal distance travelled by the ball before it hits the ground. For this, we need Vx, the horizontal velocity, and we need the time of flight. Now, the time of flight equals twice the time to the top. So using the answer that we got last time, the time of flight will equal 2 times 1.3163, which equals 2.6326. You can keep the other decimal places on your calculator. This time we should use the unrounded value. The first time we used the 12.9 because that was given to us. This time there's been nothing given to us, so we'll use the unrounded value. We need to calculate Vx. For this, we need to go back to our triangle from the beginning. And this time, we're calculating the horizontal component. So, looking at our triangle, we'll calculate the horizontal component. So, Vx equals 20 times cos of 40 degrees. You can do trigonometry, you can work that out for yourself. And this would equal 15.3209. To get the time, so we've got the time of flight and we've got Vx now. We've managed to calculate both of those. We know that velocity of x, because it is constant, equals distance over time. So the velocity of x times the time will give us the distance. Now this distance is actually the range. That's the distance we call the horizontal one. So the horizontal distance is also known as the range. Working this out, we've got 15.3209 multiplied by the time, which was 2.6326, and this will equal the distance we're talking about. So the distance works out to 40.3346 meters. Or 6 meters, which if we round would give us 40.3 meters. The last part is a descriptive part. So in your answer you should describe horizontal motion, the effect of the forces on the horizontal motion, describe the vertical motion and discuss the effect of the forces on the vertical motion. For this we need to remember what forces are acting. Now the only force is the gravitational force downwards. Which causes an acceleration of 9.8 meters per second squared downwards. So that is what we've got to remember. We're assuming air resistance is negligible, so there are no horizontal forces. That's our thinking. So when we're describing the forces acting on the ball and its flight, those are the forces. So we work out the velocity, the horizontal velocity remains constant, as there are no horizontal forces. Vertically, the vertical velocity decreases at 9.8 as it rises, is 0 at the top, and increases at 9.8 as it falls, due to the downward force of gravity. Okay, so that should be the basic answer there, and that's where we'll end this video.